want to share. So, good afternoon, all. Good afternoon. Yes, guys, I was just checking with the presenters review. Yes, good afternoon. Hope everyone had their lunch. Yes. Now let's wait for a couple of more minutes. Yes, I'm clearly audible to each one, right? Firstly, confirm that. Yes, yes. Okay. Good afternoon. Good afternoon, all. So, one more thing, guys. I have removed all the PPT slides as we are not supposed to share the PPT slides. But apart from that, I have given you the notes, okay, the readouts or the handout that you can consider for each days or whatever I taught, right? Whatever I teach every day. So that I will be sending in the form of notes. Okay. So if you see the drive link that I've shared, right, you will be seeing the student handouts. So in that, whatever the topics that I'm going to teach, I will be updating the same. So you can have a look at that every day. And followed by that, I have also uploaded the logistic regression. So under the folder called as machine learning models. Did you guys check, guys? Can you please confirm? Did you guys check? Let me share the drive link. So this is the drive link. So you can go, and then since we have talked a lot about logistic regression yesterday, what I did was I also normally show you the code part, right? So what I've done is I've included all the remaining code as well. So you can go and then have a look at it. Yes, I have shared it, Rathod. This is the link. You can have it. Yes. Okay, cool. No problem, Jay. Yes, I have to help you all. Not yet, Pratik. So you'll get your. Let me. Yes, guys, please listen to me. So what you'll be having is you'll be getting our skill wallet, our products credentials. So in that you will be asked to do some self-paced courses. So we will be giving the self-paced courses links. So you have to complete that. It's clear. So once this instructor-led training, like until next week we have the sessions. So when once we are going to complete this, then you will be backed up by projects. Is it clear? Don't worry. Don't worry, guys. You will be getting to know all your. self-taught about the theory part, right? Okay, guys, regarding the project and all, I think let me get a clarity from my team. Okay. So can we start, guys? I hope 360 people are there. 370 people. Yes, Manisha. Okay, guys. So let's start. So yesterday we learned about what is classification and that there were different types: logistic regression, decision trees, and Canaan, right? Then we also got to know about the evaluation matrix, that is confusion matrix, classification reports, and in this classification reports we have multiple things: accuracy, recall, F2 score, and sensitivity and all, right? So now what we're going to do is there are also not only these three algorithms are there, but there are still more. So one of them is our SVM. So any idea about what is this support vector machine is about? But before that, let me share my screen. Just a moment, guys. Guys, hope my screen is visible to all. Can you please confirm? Yes. Yes. So next, and also confirm, is my slides are also moving? Are you guys able to see it? Yes. Yes. Okay. Cool. So yes, guys. So any idea about what is this SVM is about? Support vector machine. Any idea? Yes, guys. Any idea? Any real life example that you can come up with for this one? Yes, guys. You can text in the chat. Yes, it is to classify. Yes, Ganesh, it is to find the optimal hyperplane to separate the data points. Correct. Question support question to note. The best or the shortest route. Correct. You can be almost correct. So it contains a hyperplane that divides two different types of support vectors. Correct. Any other answers, guys? Boundary, non-different. Okay, correct. So let's consider you have, yes, support vector machine is the full form, correct? So let's learn about this. What does this support vector machine called? To make you understand simply, I'm going to consider a real life example. Let's consider I'm going to have a two colored balls. One is red and the other one is blue. Okay. Now, if I want to throw it on the floor, now if I want to classify them, okay, classify each classes. So I can use my ruler, right? Everybody have used this 15 foot, what is it, ruler, right? 15 centimeter for scale for you to draw some, what is it, be it triangle, rectangle, these kind of things, isn't it? So what will you do? You're going to literally split two. What is it? You're going to draw a line that is going to best separate the two classes, isn't it? So here as well, what we're going to do is since we have talked about classification, and as classification is nothing but you're going to classify, meaning you're going to take a decision based on the input that you give. It has to be under some of the other classes. Is it clear? That is what we're going to use it, right? So let's consider what did I tell? So I'm going to have two candies, right? Like two colored balls, red and blue. Now, if I want to separate them or classify them, okay. Now, what I will do is I'll be directly using a straight line. I'm directly drawing a straight line, which the straight line is going to tell me that the below one belongs to one class, the upper one belongs to another class. Is it clear? Now, it would be okay if you have it in, like if you have only two types of data points, and if it is what do you say, if it is scattered linearly, you can do it by drawing one line. So what if we have a mixed color? Okay, like one mixed colors, meaning one next to the other, the different colors are there. What will you do? In that case as well, you can do it by using the concept called as kernel trick. Okay, so what is the kernel trick? Kernel trick are nothing but you can say it as a, what do you say, it's like a magic line that you can consider. Okay, so what does this does this, instead of, even though you don't have your data in which is the linear form, that linear form is nothing but you'll have two sets. You directly by looking at it, you will draw a line. Okay, but what if you have mixed colors or mixed number of data points? So in that case, what you can do is you can use it, the concept of kernel trick. So what this is going to do is, even though your data is mixed up, you will be able to classify. So what it's like, you can consider you have a balls that is scattered on the table. Now, to understand the classification, or to understand the different classes, what you can do is you can throw a couple of balls on the air. So by doing that, what are you trying to do? You're literally increasing your dimension from 2 dimensional to you're increasing through 3D, isn't it? So in this case, you'll be using this kernel trick to identify or to classify the new data points. Is it clear? Is it clear, guys? So let's start. So before that, what is this? So we're going to use the support vector machine. So what this is going to do, this is going to separate the two classes. That one, that line is the best one. Okay, meaning best one means what? That is the perfect line that is going to segregate, or it is going to classify all the two classes. Is it clear? Be it two classes. If you have two classes and it is linearly scattered, you can do it by directly drawing a one linear equation, then one straight line. But what if you have more than like different colors and scattered at different places? Then also you'll be able to scatter, or is it, classify using this SVM. How is that? Is using this kernel trick. Okay, now let's explore each one. So what is this SVM? So SVM is nothing but it's a classification algorithm, although it does apply both in classification and regression. So why do we have to use this? we're going to use this. First thing is to have the best boundary between the classes. Best boundary means मतलब क्या है, आपको एक बाउंड्री रहना है, हमारा एक बाउंड्री रहना है. जैसे हमको भी like just like we have a boundary between India and then Pakistan. In a similar way, why do we have that boundary? It is to represent that the boundary to the other hand belongs to one class, boundary to the other this end belongs to another class. So no, the same way we're going to use this SVM. So how are we going to do it? We're going to have a decision plane. So what does this decision plane is going to do? This is the line which is going to give us the decision. Given any data point, we will be able to classify depending on the line or depending on the group of the data point that is present. Is it clear? Now, what we're going to do is, so how does this going to SVM work? SVM is going to work is, first it is going to have a hyperplane. So what is this hyperplane? Hyperplane are nothing but, first let's understand the diagram. So if you see this diagram, we're able to see two data points, right? One is that green dot one, and the other one is square one, that is the blue one. Now, if you want to segregate this, you have to have the best, hyperplane. Hyperplane is nothing but it is a line that is going to classify both the classes. It's clear. Next, we have this support vectors. Support vectors are what? These vectors are nothing but the data point. These are like the line, okay, where you will be able to see the data points very closer to them. Okay, so you will be drawing this hyperplane. Okay, you will be drawing the support vectors. Okay, which will be very closer to the data point that you have. That's clear. Now you have to make sure it's clear about the hyperplane. Hyperplane is the best line that is going to separate or it is going to classify both the classes. Okay, so the support vector machines are nothing but the support vectors are nothing but these are the points, imaginary points that you can consider, which are closer to the point, which are closer to the classes that we have, right? It is those data points. Is clear? Now we'll understand here. So how does this SVM is going to work? It is going to work by creating the best hyperlane. So what is hyperlane? Hyperlane is nothing but the decision boundary. So what this decision boundary is going to do? Decision boundary is nothing but it's going to give you a given any data point, it belongs to A class or B class. So for you to have this conclusion, you have to draw one straight line or a hyperplane that you can consider. So what is this margin? So margin is nothing but this is the one. So margin is nothing but this one. So what is this margin? This is the hyperplane and these are the data points, right? So the distance between them is called as the margin. Is it clear? So if you see here, this will have less number of margin, while this one and this one will have high margin because the distance between the data points and this hyperplane is very, very high. It's clear? So there are like 4 things that you have to consider. First thing is you have to first draw a triangle. If your data is scattered linearly, then you can directly draw a straight line. Okay. So what if you have your data points scattered there at different places? So in that case, what are you trying to see? Your data, you're able to see your data being scattered multiple places, right? So in this case, what we have to do is we can consider this kernel trick. Okay. So by having your data linearly scattered, you can consider this 2D, where you will be only able to have this one straight line. But in case of 3D, you have to have it in kind of 3-dimensional way. Okay. So hyperplane is nothing but the decision boundary, meaning it is where we are going to use this line to classify both the classes. Okay. So margin is nothing but the distance between this hyperplane and the nearest data points that you have. Okay. It's clear about this diagram. Can I get a confirmation or thumbs up from the chat? Guys, hope everyone have understood, right? So SVM, we're going to use this SVM only to first we are going to draw a hyperplane, which this hyperplane is going to classify any classes. Is clear? Now, hyperplane is very, very important and the margin is very, very important. Now, we have this support vectors. So what are the support vectors? I've told you, right? So what are the point that is very closer to this margin? Okay, this hyperplane. So these are called as the support points, support vectors. Is it clear? So what are support vectors? Support vectors are nothing but the data points that are closer to the hyperplane. Is it clear? So why do we have to have that? This is the one that is going to have this most effect, right? isn't it? So value belonging to this hyperplane belongs to one class, but considering this one, it is very far away, right? So this shows that this belongs to one class and this one belongs to another class. So make sure you understand this. So support vectors are nothing but the data points where you will be able to see that is very next to the hyperplane. Okay. Is it clear, guys? So by using this hyperplane itself, you'll be able to take up some insights. Okay. So what we have, it is this is very important. So this makes SVM robust to outliers. So what are these outliers? Outliers are nothing but these are the outliers, right? The endpoints or the last point that you have. This doesn't have much impact. Is it clear? While closer to this hyperplane, this support vector, this margin will have the this hyperplane will have the most advantage. Is it clear? So this is what I was talking about. So if you have this SVM for nonlinear data, so what is nonlinear data? If you're not having a data, now if you see you're not having any one line, yeah, you're having this data point, right? So in this, if you're to classify between two classes, you're not able to do it, right? If you want to draw like this, it won't separate two classes. Or if you will draw this, it won't be classified because two data points belong to this class. So in this case, what you can do is we can classify this by using this technique called as kernel trick. So how does this kernel trick is going to do is I'm going to give you explain it with an example. So if you have a colored boxes, let's consider green and then blue. Okay, now you have thrown out on your table. Now to identify the different classes, what you will be doing is you literally able to see analyzing from different dimensions or different perspectives. Okay, so in this case, we are going to use this kernel trick. It's clear. Even when your data is not in a linear form, okay, if it is not in a linear form, then you have to consider this kernel trick. Is it clear? So what is this going to do? It is going to map the data into higher dimensional space. Is it clear? So whenever your data is not scattered in a linear form, and if it's scattered in a non-linear form, you can use this kernel trick. Okay. So this is what I was talking about. So this is linear SVM and versus the non-linear SVM. So how are we able to do it? You're able to do it if you have like these are linearly scattered, meaning what? You're able to draw a linear line. Okay. Just by considering this one straight line, you're able to classify these two classes. But what if you have classes? What if you have data points just scattered all over the place? So in that case, what you can consider this? You can consider this kernel trick. So what is this going to do? It is going to analyze your data from different perspectives, or it is going to map your data into higher dimension rather than looking at one dimension or one or two dimension. You can look at your data point from different dimensions. Is it clear? I hope you're all taking notes. So please draw this diagram to make you understand about this linear SVM and the non-linear SVM. Yes, Supriya, I'm clearly audible, I guess. Can you guys please confirm me, guys? Am I audible to others? Or is it the same with everyone? Yes? Okay, cool. Yes, guys, hope you understood this diagram. Now, you have this common kernel functions. So what are the common kernel functions? You can use this linear kernel. So when do we use this linear kernel is when you have your data being scattered in linear form. Okay, so this is one linear form. Okay, linear form means what? You are able to draw a linear equation line. Okay, a straight line by to classify two classes. What if you have multiple data points which are scattered multiple in different ways? Then we have this polynomial kernel. Is it clear? So this polynomial kernel is for non-linear boundaries. Is it clear? So next we also have this radial basis function. So what is this for? This mainly used for non-linear boundaries itself. And if you want to have any kind of data more complex, more number of classes, then you can consider this radial basis function. Is it clear? Is it clear, guys? By default, what we're going to do is we're going to have this RBF as the kernel. Okay. So you have to make sure to choose the respective linear. If your data is about, if your data is linearly scattered, then you can consider linear kernel, or if it is scattered into like in multiple mixed up with a data point, then you can consider which is not linearly scattered, then you can go with polynomial. Okay, and if you're having more classes and you're not even able to find a clue, then you can have this radial basis function, and this is the default choice that everybody uses. Okay, so what are the SVM use cases? Where do we see these SVM being applicable as image classification? So how does this image classification is going to do is, it is similar to our, what do you say, we unlocking our phone. So how do we do that? What is the backend is happening is, we are going to use this SVM concept. So we are going to have this data. Okay, we are going to have our data using this kernel trick. So here we have learned about this radial basis function, right? So what is this going to do? It is very popular for complex data that we have, that is non-linear boundaries. Since do we have any kind of linear stuffs in our face? No, right? It is scattered in different places and it has to identify all the edges, right? So in that case, what we're going to do is, we are going to throw this into using this higher dimension phase. Okay, in a higher dimensional phase, we are going to throw our data. Then by we will be creating some matrix or drawing some lines. Based on this itself, we will be able to unlock our phone. Is it clear? Next comes this to text classification. Text classification is also using this SVM, and also handwriting recognition, classifying handwriting characters. So these are all the applications where where we will be able to say this support vector machines. Is it clear? Is it clear enough, guys? So next we have this. How do we implement this SVM code in our model? That is the code. So how do we do that? To use this SVM, what is the, where are we going to use it? Employ it. We are going to go to our sklearn and then import our svm.svc. Okay, this is the classifier. Is it clear? So from support vector machines, we are going to include the submodule called as SVC. So what is this SVC? This is support vector classifier. Is it clear? It's clear or not? Next, we also have to use this C, regularization and then kernel. Next, we have to find this K, right? So we have to, depending on our data, we have to change the kernel, that is the K value. So to do that, what we're going to do is, we're going to use this grid search CV. Okay, so what is the grid search CV? So these are all the parameters that we have, like parameters are nothing but this one, C and then kernel K. So if you want to have the best values for these things, we have to consider this grid search method. Okay, so by having this, we will be able to have this optimal parameters. By using these correct perfect parameters, we will be able to classify the given data. Is it clear? Is it clear, guys? Any questions? So I think it's clear, right? So I forgot to mention this support vector machine in the previous last class. So I have done this. What is CRC? I'm not able to get you. Yes, sir, CRC me. Any doubts? Uh-oh, forgot about. Hmm. Yes, guys, I've completely forgot about KMN working out. Hmm. I'll do one thing. I'll upload the what is that solution in a drive link. Okay, try to understand it, or else I'll explain it to you tomorrow. Okay, just make a reminder in my phone regarding this KNN. I hope it's clear, right? So can we go ahead with some coding part? So did you guys go and then check about the logistic regression that I shared in the Google Drive? Guys, please confirm me. Yes. Did you guys not understand anywhere? So I'll do one thing. So whatever the I mentioned in the earlier class at the start of the class. So PPT will not be shared, but better than that, what I'll do is I'll share the notes for each day. Okay. Now we have talked about SVM, right? So I'll send a what is that approachable where you can understand with real life example of whatever you have learned. So short summary could be, so SVM we're going to use this support vector machine is to first thing is it can be used for regression and as well as classification. Now in terms of classification, how do we do it is we're going to draw a hyperplane, or you can consider a line which is going to best separate the classes. Okay. So it will be applicable when you have your data being scattered at a linear place where you can literally see and then draw a straight line. But what if you have your data points scattered at multiple mixed ways, like one next to the other? Okay, so in that case, what you can do is you can also classify it using SVM. How we can do it is you can consider the kernel trick. So what is the kernel trick? So kernel trick is going to analyze, or it will be able to classify given your data being scattered at, like looked at a higher dimensional space. Okay. Is it clear, guys? Can we go ahead with some what do you say, some coding? So what we'll do is I'll just open a new tab and then type in the SVM and then KNN we can do it. Logistic regression is it is very important, and it is only you'll be using it when you have binary classes. That is two classes. Okay. Now I've named it. So let me share my screen. Guys, can you please confirm me? Is my screen visible to all? Everyone? Yes. Pratik, whatever the message that you have typed, it feels very touched by you, like from your end. Yes, I'll be keeping on. Let's have this talk later, but let me finish this content. Okay. So, has everyone opened the Google Notebook, Colab Notebook? Confirm me in the Q&A. Yes, guys. So, any idea? Has anyone heard about this word, Iris dataset? Anyone? Yes. Iris dataset. Not. So here, what we're going to do is Iris dataset. It's like a flower classification here, based on the data that we're going to have. Okay, so let's consider you will, depending on your sepal length, sepal width, petal length, and then petal width, you will be able to classify these. Like these are all the input that you have. Based on this, you will be able to classify the different classes. So what are the different classes that we have? We have Iris setosa, what is that? Next we have versicolor, next then virginica. So these are the different classes that we have, right? So if you observe here, we have three classes, isn't it? So let's do one thing. First, let's get into the code first itself. Then, if you are able to understand the what do you say, the data set, then you'll be able to have some clarity. Okay. So please, everybody, open your Google Colab notebook and then start doing along as with me. So first thing is, let's import. First thing is what? Give a name for your file, your notebook. Then click onto that connect. Now after having clicked, now we have to import all our libraries, right? So now what we can do is, now let's import all our code. So let's import the pandas as PD. Next, import our NumPy as well. Right. Next, let's include about matplotlib as well. If you're going to use it later, import matplotlib. Yes. Yes. Next, we have included pandas, NumPy, matplotlib. Now, since we're going to talk about all our machine learning models, first thing is what? Let's include our first. Let's get into our sklearn, and then get our model selection. First thing is what? You have to select your model, right? So to select that, I'm going to use this sklearn. From this sklearn module, from this library, I'm going to use this model and then select. This is the model selection. This is the code. So what am I doing? I am importing train test split. Okay. So why do we need that train test split? The idea, guys? So what is this? So here you are going to sklearn module and then selecting the first thing is you will be getting your data set. Then once you've got your data set, now you have to do some pre-processing. Then once you have done your pre-processing, now you have to split your data set to multiple things, right? So how are you going to split your data set? You'll be splitting your data set into using this train test split. So in this case, what we're going to do is we are going to, if you're going to have 100%, let's consider you have 100 data samples. So in the 100 data samples, what we're going to do, we're going to split that into 80% for training and 20% for the testing. That is what you're going to do it in your examination, right? In your real life. So you will be trained before the examination. You will be given some 10 to 20 questions to prepare. And in your examination, you will be asked to write the 2 questions, right? 2 to 5 questions. So it is the same case here as well. So what we're going to do is, we're going to first train our machine learning model. That is our machine. That is our beat any model. We're going to train it by splitting the data. First, we're going to train it with maximum data, and then once whatever we have learned from the training data, we will be using that for the testing data. Okay. So for that, first thing is we have to split our data. Now let's include all our linear regression model. We don't want it. Let's go to, as we have talked about, SPM, and then this one decision tree also we have learned, right? We can also consider that as well. So we can consider this a decision tree. Let's go to decision tree. So from sklearn, yes, tree. Now what we're going to do is we are going to import our decision tree. Okay, so it is case sensitive. Make sure you're going to use the correct capital letters or small letters. Is it clear? So decision tree is done. Now let's include this one as well. Let's include our KNN neighbors from sklearn. Very bad at sklearn out neighbors, right? I'm sorry. Neighbors, you're going to include import your KNN. That is KNEIGHBORS sorry, init, where is this T? Neighbors classifier, right? This is done. Next. Next, what are the next thing? Any idea? What are the last thing that we have to include? Now let's include our some of our this one. So to include our we're going to sklearn. Yeah, for sklearn, for SVM, it's I think SVM from yes sklearn.svm. We have to include import SVS. Yes, we have to include SVC. Sorry, support vector classifier. This is done. It's clear, guys. So what have we done? We have included our first imported all our libraries, that is import NumPy, pandas, and then matplotlib. Then we have included from the model selection to test to split our data. We have used this train test split. So one, this is done. What have we doing? What are we trying to do? We are trying to import all the other models. So here we have included decision tree, name, but what is this KNN and then SPM. That is SVC. Is it clear? Now what we can do is we can download a data set. So as if you have your data set in your, you can get this data set, what is that? Iris data set from the Kaggle itself. Okay. By default, what we can do is, since this data is being available in our, what is it, sklearn data set itself. So we have this concept. So let's first run this. So before that, sorry, I forgot to mention the evaluation matrix. So what are the evaluation metrics that we have to consider? There were so many evaluation metrics, right? So what are those? So from those, what we can do is, we have, what are the evaluation metrics, guys? Can I get a confirmation? Yes. Any other? Yes, guys. I'm looking at the Q&A. So what are the evaluation metrics that we're going to consider for classification algorithm? Yes, TP, FP. This will all be known in where? In confusion matrix, right? So what is the other metric that we're going to consider? We have classification report as well, right? Isn't it? So for that, we have to include a scalar. Yeah, automatically has come. Yeah, are you guys able to see? So we are mainly we're going to use this accuracy score. Why accuracy score? So this accuracy is going to tell how much of your decision is correct, be it the yes class or no class, be it the yeah pass or fail class. So how accurate you were to classify between the two classes. So this is very important, apart from precision, recall, and all those things. Okay, and also we are going to consider this confusion matrix and classification report. So these are the evaluation metric that we're going to consider. Now let's run this. So this is done. Now what do we have to do? We have to. So what do we have to do? We have to import a data, right? So where can we get the data? First, that is, since I've mentioned, this iris dataset can also be gotten from Kaggle, okay, and it is also can be got from the sklearn itself, okay. So let's get it from sklearn library itself. So sklearn dot data sets, okay. So you have this, yeah. So automatically it has come, right? So what are we trying to do? So here, right under this sklearn module, we have so many data sets. Okay. So from that, what are the data sets that what do you consider? Here we are going to consider only iris. Okay. So what are we doing? We are considering this variable name called as iris and storing all the data that has been present here in this data set. Is it clear? So let's run this. Sorry. Yes. Yes, Ketan, now we start. Now it is done. Now whatever the data that we has, let's consider. So there is some code how we can convert this data that you have. Let's consider whatever the data that is being there in this data sets, right? It might be of different CSV file or any kind of file format. So to convert that into our, what do you say, a table form, okay? So for that, what we have to do, we have to first convert that into a data frame, right? So in this, what we're going to do is, first, let's separate this. So to separate this, I'm going to use my pd dot data, sorry, data frame. Yes, yeah, this is the correct. So what am I doing? I'm going to my iris data set and then only taking the data points. Okay, this is my column name. And here, what am I doing? So these, what are the column name that I have? So right under the column names, I have this column iris dot feature names. It's clear. This is my column name. So in this, from this iris data set, what am I going to do? I'm going to get all my feature names. These are the column names. Okay, is it clear? So this is my X and this is my Y. So what are this X? X are nothing but the input variable that you're going to get, and Y is nothing but the output. Okay. So let me run this and then show you. Let's run this X. You'll be able to get. Yeah. Are you guys able to see here? So what have I done? I've got into all this data. Okay. So how have I got it? So I went to my iris. This is where my data is being stored. So I put in that into a variable called as iris. So after from this iris, what am I collecting? I'm collecting the data, right? So what are the type of data? Columns from plus the feature names. Okay. So if I want to have the CX, are you guys able to see? I'm able to see only what is this? Sepal length, petal length, and then petal width. So based on this, okay, based on these input values, you will be able to predict the Y value. So what are these Y values? Y values are nothing but the classes that we can consider. Okay. Is clear or not? On this. Are you guys able to see here? So here, if you see by default, here we don't have any kind of zero. What is it? Iris names and all. So by default, what is going to do is by 0 is going to represent iris setosa, versicolor is going to represent 1, and then virginica is going to consider the value of 2. Is it clear? Is it clear or not? So let's get the first row. So first row has the 5.1, 3.5, 1.4, and 0.2, right? So considering these data points, okay, you are able to predict that it belongs to the class 0. Is it clear? I hope it's clear, right? So since machines can't learn about, is it the same with everyone? Is it the same with everyone, guys? Just confirm me. Is my screen fixed? Can anyone please confirm me? Okay, let me stop sharing it and then share it once again. Now is it visible? Can you guys please confirm this on the chat? So Shreya, what are the 0, 1, 2 values are nothing but these are the classes. Okay. So let me tell you. So you can consider, where is my code? Yeah. You can consider this since you're not doing any kind of pre-processing, right? So you're directly importing from the SQL data set. So you can consider, so let me add the text, and then, so here 0 is going to represent Iris setosa. Okay, now, sorry, 1 is going to represent Iris versicolor, I guess. Yeah, versicolor. And 2 is going to represent your Iris. Now the last one is virginica. Okay, so since machines can't learn, understand these, what is that? Textual form or categorical form, it has to be converted into, what do you have to convert into? It has to be converted into a numerical form, right? Either 0 and 1 on the numbers form, then only it will be able to understand, right? So in this way, we are going to have this point. Okay, is it clear? Is it clear? That is what we are getting. So given this, yeah. So what are we trying to do is, this is our x. So x are nothing but the independent variables that we have, right? So given these number of values, these values for sepal length, sepal width, and then petal length, petal width. So what are we able to do? We are able to predict it might belong to setosa, versicolor, or virginica. Is it clear? So there are three classes that we have to classify depending on the data that we get. Is it clear? Yes. Is it clear, guys? I hope it's clear. Now, let's get into our coding part. So this is done. What have we done? We have imported all the necessary libraries, imported data set, and we were able to split the data into, what is that? Get to know about your independent variables and then dependent variables, right? Is it clear? Now, what we can do is we can add our target names. Okay, so what we can do is, let's, to have this iris setosa and all these things, let's consider this code, that is my, so I'm going to have this variable name called as my names. So this, what I'm going to do is, I'm getting to my PD. So if I want to consider the series, so what are the series represent is, the series represents a one dimensional curve. Okay, is it clear? Either it can be horizontal or vertical. Okay, so in this, what I'm going to do is, I'm going to get all my, what I'm going to get, I'm going to get all my variables. Okay, that is the column names. So let's get the target names. For that, I have to go to my iris. This is the iris, and then I'm going to have my target. Okay, so from target names, I'm going to consider. So from this, what is the thing I'm going to consider? I have to consider the independent variables, right? So these independent variables are nothing but 0, 1, and 2, isn't it? So inside these y, what are the values that I have? 0 and then 1, 2, right? Is it clear? Now, if I want to get to know about the names or the what is that, categorical ways, then I have to consider. I have to go to my convert that into series. Series are nothing but one-dimensional space. So I'm going to convert that into one-dimensional space with what data? With the data from the iris. So what are the target names? I have to consider my y variable. Okay. So in this, so what I'm going to mention, let's consider, I'm going to mention as name it as species. Okay. We consider that as a species. Is it clear? Is it clear or not? Next, I'm going to convert these. First, let's run this. Data must be non-dimensional strings. So, but instead we have 1 into 2. This data we have done. Next we have this done. 5 we have loaded our this one. Then x values is feature names we have done. Flower time is also we have done. Then first let's split this into different spaces. Okay, we'll go on with we have got this. Yes, iris we have got it. We have converted that into a species. So coming, what are the data set we have about? We have converted, loaded our data set. Then we have converted our column names as this one. And why this? Okay, sorry, guys. So here I have considered series because since I have only one column, right? So target has only one column, isn't it? So this has to be series. I'm sorry. So there I considered. So guys, make sure you're going to have this data frame only when you have multiple columns, that is rows and columns. Since I've considered only series is that since it is a one-dimensional space. Why only one-dimensional space? Because I have only one column. Okay, either it can be horizontal or this one, vertical. Sorry, please make these changes. In the Y, you have to have this pd.series, not data frame. Okay, now we can explain. Now we can go on and run this. Is it clear? Now it's working fine. I hope it's clear, right? So now let's what is that? Have all our column names and what do you say? The rows and all the columns. So to have that, let's create a variable called as df. So this is a df name that I can consider. Now what I'm going to do is I'm going to concatenate. So what is concatenate? He's going to connect or is going to add all the other things. So for that, I'm going to have this concat. Sorry, concat with what data? I have this x and then y, right? So that I have to mention. So capital X is what I have considered. So please make sure whatever you have mentioned, you have to mention the same. So for Y, I have considered the new name as Y names. This is what I have considered, right? Y names. So that one you have to consider. Is it clear? And let's to include only columns, I'm going to have to consider axis equals 1. Okay, sorry, axis equals 1. Is it clear, guys? So let me run this. So this is done. Now to get to know about your first 5 rows, what you can do, you can include this one first. Let's run this. Are you guys able to see the difference now? So initially, what is the data that we had? Initially, we had our in terms of y, we had only target as a 0, 1, 2. Isn't clear? Now, if you want to, if we wanted to know about the 0, 1, 2 class, what did we do? We had converted, we had got into iris dataset and then got the target names. And what is the column name that you're going to have? You're going to have it as species. Okay. So in this species, what am I doing? I'm having storing all this data in one dimension. That is in this one column. Is it clear? Is it clear or not, guys? Now, if we have to print about the first 5 columns, we can directly use the df.head. And if you don't specify anything, by default, it's going to consider the first 5 rows. Is it clear? Now, are you guys able to see? Now, let's consider this df.tail as well. Now, are you guys able to see? So, depending on the sepal length, sepal width, petal length, and then petal width, you're able to classify between these classes. Clear? I hope it's clear, right? So, but before that, let's find we have around 150, right? So it is around to know about your shape of your whole data set. You can use this data.shape. Okay, then you'll be finding your number of columns. So how many columns we have? We have 5 columns and then 150 records. 150 rows. Is it clear? Is it clear or not? Yes, guys. Is it clear or not? So this is about our data. Is it clear? Now, what we're going to do is, this is Shreya, did you get an idea about what is the 0, 1, 2 and all? To explain you this, I have got this code. Now, what we can do is, let's now dig onto our variable. Okay, let's split our data. So you can have this code mentioned as data splitting. You can consider. So display. What is spelling of splitting? Yes, speak. Yes, data splitting you can consider. So now how we can do that? So how are we going to do it? So let's include our X variable. So let's consider capital X. So on this, what I'm going to do is I'm going to have all my data. So what does this data is going to have is all these rows. So what are this? All these rows, sepal length, sepal width, petal length, and petal width are there, right? So these are the datas, okay, from iris that I'm going to consider, okay. So for that, what I'm going to do, I'm going to go to my iris data and then have only data. That is the call names under leaving the species, okay. Now let's consider my other data set as well. That is y. So in this, what I'm going to consider, I'm going to consider iris dot target, okay. It's clear. So what does this x? X are nothing but the independent variables. So y are the dependent variables. So y is the dependent variable. Since given these values itself from the x values, you are able to predict that does it belong to what is it, Virginica, Setosa, or versicolor. Is it clear? Now you have split our data set. Is it clear? You know about your independent, that is the x and then y. Now split that into 80% and then 20. What are the 20%? How can we do that? So we have this code, right? So what is that? So it's extreme and sorry, y train, sorry, x test you can consider. Next, you can consider y train. Yes, almost has come. So what is this? So you're going to have x train and then x test, y train and then y test. So you're going to use this train test split. So this is the library model that you're going to use to split. So how are you going to split? You're going to split it with x and then y. So what are the x and y? These are the independent variables and these are the dependent variables, right? So these will be known here. Is it clear? Now, how are you going to split that? You're going to split that with test size of 20%. Okay, test size 20% leke, uh, remaining we have 80%, right? That will be sent for training. Is it clear? And the random state mass 42. Why do we have that random state? To stock the randomness that you're going to get in your output. Okay, to get new what is that random output for accuracy or classification report or classification report or confusion matrix. To have the common answer or value, you have to consider the random state. Okay, so this is done. Okay, let's run this. Now if you want to go back and then analyze or get to know about your x test, so what you can do, you can go and then type in your x test, okay, and then run it. So you will be able to see these are all the input values that we have: 6.1, 2.8, 4.7, 1.2. So these are all the values from the first record. Is it clear? Sorry, this what? So xtext में हमको 80% data लेता है ना. So that is this one. These are all the data point that xtest has taken. Okay. Now what in terms of y test? Sorry, y train. Y train has to be in this one. Is it clear? So if you observe here, so x train क्या है, x test क्या है? Sorry sir, I should have gone with x train. Yes, are you guys able to see? So for each value, let's consider you have this 4.6, 3.1, 1 point, and then 0.2, right? Given these value, you're able to get the output as, what is that? For x train, you should get the value of y train, right? The similar way for x test, you should be able to get the value of y test, isn't it? So for the first row, 4.6, 3.6, 1, and then 0.2, you will get the value in y train. Is it clear? Now you can go back and then see here. So what is the first one? It belongs to 0th class. That is, what is the first one? We had the first one as Setosa, right? Is it Setosa? Yes, it's Setosa. Is it clear? So this is to make you understand what are these X train, Y train, and how are they split between 80% to 20%. Okay. Now, if you also want to get to know about your X test को कोई आपको पता होना चाहिए, तो you have to go and then type in next. Then sorry. Then run this. So you will be able to see that for testing, for training, they have taken around this much. Okay, these are the data points that they have taken, and they have trained the model. Now for testing, how much have they taken? They have taken around only this much. Is it clear? Now we have also got to know about the y-test output as well, right? But what are we going to do with our model? That will be taken care by the different models. So how are we going to do that? How are we going to use the different models? So there are also code. Okay, so let's start off with our first code, that is decision tree that we can consider. Okay, so to have the decision tree, so what is the first thing is, you have to, let's sorry, not the code, let's include our text. That is, I think just a moment. Yes, hope everyone are here, right? Just bear with me for today. This is, since this is a coding part. If you've understood, if I give a break, you will not be in a line. Just bear with me for a couple of more minutes. This is done, right? So let's talk about this decision tree. So we have our data. We have split our data into X and then Y. We have, what is that? Got our training data for 80%, and then we have the remaining 20% for testing, right? Now we have got to know about the X test and Y test, all right? हमको X test भी पता है, and then हमको Y test भी पता है. But how does the machine is going to learn? Machine is going to learn by having this model imported. So I'm going to create a, what is it? Variable name called as tree model. So in this, what I'm going to have, I've used this, imported this decision classifier, right? Yes or no? You can go and copy this and then paste it here. Or you can directly type it as well, it will automatically come. So it's decision classifier. So what am I doing? I am having this decision classifier stored in a variable called as tree model. Okay, you are initializing it. Is it clear? So let me run this. Now, what I have to do, I have to train my external and my train, right? So to train your model, what I'm going to do is I'm going to have this tree model. So let's use this tree model. This is where I have initiated my decision tree classifier. So in this, I'm going to fit. I'm going to use this dot and then dot use this keyword called as fit. So what am I doing? I'm fitting the model. I am using this decision model and then fitting into what? On my training. So what are my training data that I have? X train. Sorry. X train and then Y train, right? So what are you doing here? You're literally training your decision tree classifier on X train and then Y train. Is it clear? Now run this. So you have, it shows that you have trained your whole training data. Now, what do you have to do? What do you have to do? You have to predict on the X test, right? Yes or no? हमको X test को लेके we have to get to know about the Y test. हमको Y test भी पता है, but if you're going to use our decision tree classifier, we have to predict the value, right? So in classification report as well, we have two things. One is actual values and the other one is predicted values, right? So actual values are nothing but we know the X test and also the Y test from the data set that we have. But you have to compare that with the predicted model, right? So prediction kaise banate matlab we have to use some models. So here we have used the decision tree classifier, right? So let's have this as Y. We're going to predict the class, right? What are you can have this predicted tree. So in this, what are you going to do? You'll be predicting on your test data, isn't it? So you're going to use this decision tree model classifier and then predicting on what? You'll be predicting on your X test. Is it clear? I hope it's clear, right? हमको पता है from our naked eye, you will be able to see given these data set. What is the data set? Yeah, given these data sets, you're able to see. So 6.7, 3.5.2, 2.03 there. तो हमको पता होता है. Yes, बचने का मतलब. So how will the company, how will the model is going to learn, how will the company, how will the computer is going to know is you have to use some models. So here I have considered decision tree, right? So I have to predict on the X test, right? So whatever the output that I'm going to get, it has to be the same with Y test, isn't it? So I'm going to print this Y. Yeah, this is the one that I've got it, right? So let me run this. This is what you've got, right? So you have used this decision tree model on the X test, right? So you have got some answers, right? That is Y prediction tree. Now you also know this X test and then Y test, right? Now let's print this Y test. Sorry, it has to be underscore. Yeah. Are both the things aligning? Can you guys check? Both the things are aligning, right? Yes or no? This we know the X test and also the Y test. But how are we going to use? How are we going to let the machines understand, the computer understand this by using a respective model? Okay. So for that, we're going to use first. We're going to initiate, create a variable, use this classifiers and store the variable. Then we're going to train it on the X and then Y train. Once you have trained it, so it would have learned, right? Then whatever it has learned, we will be able to predict it. Okay. Now, are both the things aligning same? Yes or no? This shows that our model is performing very well. Is it clear? Now, to know about this, what do you say? This there is some respective code, right, for confusion matrix and all. Any idea about this? How we can have this? Yes, guys. You have trained your model. Now you want to find the confusion matrix for this. So how are you going to do it? So there is also a specific. Let me add a text as well. So confusion matrix for decision tree. So how we can do that? Let's include the code. So let's create. I'm going to create a variable called as conf underscore. We can consider matrix for my decision tree. I can consider. So this is my variable name. So this is what I'm going to store. I'm going to store. Yeah, you can consider this decision tree. So we're going to have this confusion matrix between the Y test and the Y prediction, right? So Y test is nothing but we already know the output. That is the actual values that we have. So Y prediction is nothing but that is what we have got from the model, right? Isn't it? So let's run this and now let's see our confusion matrix. Yes. Are you guys able to see here? Clear, guys? So in this way, you will be able to classify between the classes. Is it clear? Now, if you also want to get to know about your different types of this one classification report. So how do we do that? We also do it by having a what is it code called as, let me have this code as well. Classification report I can consider. Let me add. So let's have this class report or tree I can consider. So in this, let me add my this one. Oh, I literally forgot about accuracy as well, right? First thing is what you need to find about your accuracy, isn't it? Yes or no? So for accuracy as well, you can have this code mention. What is that is? You can have this accuracy score underscore between the two things. Okay. So let's have this first create a variable called as first let's create this. I'll create along with this itself. So yes. So what am I doing? I'm creating a variable called as class report tree. So in this, what am I storing? I'm showing the classification report of my y test and the y predicted class tree, isn't it? So y test we already know from the data set. So y prediction underscore tree is nothing but the output that we have got using the decision tree. Is it clear? Now let's also get to know about this first have our accuracy as well. So let's create an accuracy what I can consider. This is the variable. So in this, what I'm going to have is I'm going to have this accuracy score. Okay. Yeah, this is what. So I'm going to have this accuracy score. On what I'm going to do, I'm going to check it with both my y test and the y prediction, right? Isn't it? Followed by your sorry. Y pred underscore tree, isn't it? So what I'm doing, I am finding the accuracy on the y test and the y predicted tree. Next, what am I doing? I'm creating a classification report, isn't it? I'm initiating. Let me render this accuracy score and then followed by this decision tree as well. Now, are you guys able to see the output? First, let me run the accuracy score. We have got the accuracy score. Multi-classification is function computing subset accuracy. Okay. So what is saying is it exactly matches all your this one. Yes. Are you guys able to see here? 0.5 for the predicted one. Yes, this is the one. So just a moment. It should be first giving you accuracy. We have got our predicted class correct. We have got our accuracy as well. So what does this show us? Since it is a multi-level classification, this function subset accuracy must be simply match the corresponding set of labels in the byte row. Okay. Indicator. So what it is doing is, since it is giving you in terms of floating value, so if you have these kind of values, it will be able to give you, but it's not a problem. So let's get into our classification report. You will get this, don't worry. What we have done. Sorry, sir. You get this classification report. You will be so if you observe here, you will be able to see that precision recall. Okay. Are you guys able to see the this one? I think it's not clearly depictable. You should have one below the other. I don't know why it is happening to this. So please guys do this on your end and then check the output. You'll be having the in terms of boxes like precision, recall, or the difference score, and then support one below the other. You will be able to see it. Just check once from your end. Is it working? Okay, okay, okay. Do I have to have this print? Okay, let me have this under print. So let me use it. You can also use sprint as well. You can go to very classification report on this. Yes, this could be done. So what am I doing? I'm written this. Yes, correct. Yes, sorry. Thank you. I think who's this one? Yes, Priyanshu. Thank you so much. Yeah. Now you're able to see the output, right? So just have this. Sorry, just have this print. So you'll be able to see the output. And coming to, I guess this would be the same for accuracy as well. And I can consider accuracy score. Yes. And inside these, I can mention the YY test. And my Y predicted tree. Yes. This is done. Now let me get there. Yes. I guess able to see this one. So I literally forgot to have this print at the start. Hence, it was not able to print it correctly. Okay. Now, what you guys able to see, you have literally got the perfect accuracy, right? It's clear. So this is for, sorry, this, we copy this, then add a new code here, and then close it here, then add a text as accuracy. Okay. You can see the accuracy. So accuracy is one. So what does it represent? There is not even a bit of a single 1% of error that you're getting. Is it clear? So in a similar way, what you can do is you can do it for KNN and 1 minute. You can do it for KNN and as well SVM. Okay. So let's until then please have a break for 5 to 10 minutes and then we can come and then I'll show you the code. So as we have less number of, yes, it doesn't maximum belongs to, it does when you have your accuracy of one, it belongs to overfitting itself. Since we have less number of data sets, so there is no need to go back and then optimize your data sets and optimize your steps to remove this overfitting. Okay. Yes, guys, please take a break for 5 minutes or 5 to 10 minutes. Then we can resume the class and then complete the what do we have? We have KNN and then SVM. Okay. Do you want me to continue the same with the decision tree SVM as well? So can I give that as an homework or something? Did you guys get an overview how to train a model? So this is the overall thing that you're going to do. Okay, first import your data set, get your data collected. If you have to do some data pre-processing, you can do it later. Next, first thing is we have to have this x. What are your independent variables and then dependent variables? And then once you have done that, you have to split that into 80% to 20%. It depends on you. Either you can consider 70 to 30 or 80 to 20%. It is not that you have to consider only 80 to 20%. Is it clear? Then you can include the multiple uh, models. Then start building your first, train it using this model dot fit on the exchange and then train. Then you can do the prediction on y test, sorry, x test. So next, once you have your y prediction, that is from your model, you have to compare that with the y test. Is it clear? So to compare both of these, you will be using confusion matrix, right? And also understand the overall performance, you will be having this classification report. So this classification report, you will be having precision, accuracy, recall, IF2 score, and also support. Is it clear? So I think it's been a couple of days, right, that you haven't had a quiz and all. Now let's check. Just give me some time. I'll prepare the. I'll do one thing. Let me share my screen. I hope my screen is visible, guys. Yes. So now I'll just give you the sample SNN, sorry, SVMs, and then great. Use another account. So, like previously, we had considered these models, right? So, what are the keywords that we have used? To use this decision tree, we had considered decision tree classifier, and to consider KNN, we had considered KN neighbors classifier, and to use this SVC, that is support vector classifier. We had used this one, right? So, in the similar, whatever we have done it here, right? So, we had created a variable called as this one, tree model, and then we have imported this one, right? In the similar way, you have to do it for SVM, sorry, SVC, and as well as KNN. Okay, so now let's do it for the KNN. Okay, any idea, guys, how to do it for KNN? So let's have a model. I'm going to create this quiz. So here I'm going to consider my K neighbors classifier. So here there were like we had these classes, right? So depending on how classes, how neighbors, how many neighbors you want to consider for your this one, you can choose the k value, right? So here, like given a new point, how many nearest data point that you want to consider that that it belongs to a particular class. So for that, you have to mention that with this one, that is n neighbors classifier. Neighbors, yeah, neighbors is equal to I'll consider 3. Okay, now just a moment. Include classification regression, linear regression, logistic regression. Now, what am I doing? I have initialized and I've considered the k values as k values as 3. Now, let me train it using this train underscore sorry. This is my model name that I've considered. So in this, I'm going to first let me create a first let me directly train it using this fit on my X train and then Y train. So this is done. So what am I doing? I'm training, right? Using this KNN model. What does the KNN model have? This is the one. So clear? It is going to have 3 neighbors. It is going to consider the nearest 3 neighbors. Is it clear? Now Let me run this. Now let me predict. For prediction, let me create a variable called as spread knn. That in this variable, I'm going to have knn underscore model and then dot. I'm going to predict on my testing data, isn't it? So let me have my test data. So this is done, isn't it? So now if you want to print this out, I'm going to use spread. You will be able to see your prediction knn. Now let's check our y test as well. So this has to be the same thing, isn't it? So this is the y test. This is the actual value that we have got from the data set, and this is the output that we have got from our model. Is it clear? Now, in the similar way, you can do it for finding the. You also have to find the classification report and also confusion matrix, right? So just follow the same thing as we have considered here for confusion matrix. I consider confusion matrix underscore y test and then y prediction tree, right? So in place of y prediction tree, you have to consider this a KNN tree, sorry, KNN model. Is it clear? Sorry, KN print underscore KNN. That is what we have used this one, right? Yeah, this one. Print underscore KNN. Is it clear? So please do that. And also do it for this SVM as well. So SVM में हमको तो दो लगता है ना. So for SVM, SVC. So now in this, what I'm going to have is, let me have it. So see, here we have two things, right? For a SVM, one is for linearly separable data points, the other one is non-linear, right? So in this case, to consider this linear ways, you have to consider this code as, you have to consider, we have included our SVM model, right? So let's consider SVC, sorry, underscore linear, we can consider. So in this, what I'm going to do is, I'm going to include the kernel as linear. Yeah. Are you guys able to see the code here? So what am I doing? I am going to my SVC. This is my a classifier. So in this, I am giving the kernel value. So why do I have to give the kernel value? Based on this itself, you will be able to judge. If it is a linear, it will be considering a different one. That is, we had learned three types of classifiers, right? So what are the three types of classifiers? You guys make a note. So here we have linear kernel, polynomial kernel, and the last one is radial basis function, isn't it? That is RBF. So RBF is mainly used for like having multi-classifications or different kind of features if your data is complex. So we're going to go for this linear kernel when you have your data points that are linearly separable. Okay. So in this case, what I'm going to do is I have to include this linear. So is it clear? So let me also contain my random state as well. Random state as 42. So this is done. So I have initialized and stored my kernel values as linear. Now, what I have to do? I have to fit right. So this is my so this is, you can directly have this SVC, but given this, you'll not be able to get your data, give the computer the idea of is it a linear or non-linear. So in this case, if your data is about linear, you can consider linear, or if it is not that, there is another one. What is the other one? I just mentioned in this one. You can have the, if it's linear, you can have the kernel equals to linear, or if it is, I'll have it in the comments. Yeah, if it's linear, you can consider the kernel as this one. If it's If it's non-linear, command is not executable. Okay, you don't have to worry. You can consider kernel as kernel equals to, you can have told, right? So what is the other thing? If you want to learn about more complex things, what kernel, you can consider radial basis function. So to have this radial function basis function, you can include the keyword as RBF. Okay, is it clear? So what is that? RBF. So you can have RBF. Is it clear? And you can mention the what is that random sheet as well. Is it clear, guys? Is it clear or not? Was this done? 15 questions. So just give me 3 minutes. I'll prepare the your quiz. Meanwhile, I request the others to complete the remaining. Okay. So this is for your reference. Let me add in the text itself. Clear, guys? So in place of here, if it is linear, you can consider this linear. If it is not linear, you can consider RBF. Is it clear? So in the similar way as we have done it for decision tree and then KNN, you have to do it for this one as well. So this you can consider as a homework. Is it clear? And for a reference, what I'll do is I'll also prepare a notebook where you're going to have a clear understanding of what are you going to do with necessary comments and also the notes as well. Okay. So please start doing this. I hope it's clear, right? Hope it is taken down as well. Yes, Pratik, I'll do one thing. I'll share the whole Google Colab. I'll have a good commenting as well for all the code that I'm going to have, and then I'm going to share it to you. Okay, but please do what is the try it from your end as well. So do it for SVM and then KNN, and also try to upload the KNN solution as well if possible, because we're running out of Super Shreya. So do it for the other one as well. Like SVC, is it for linear or non-linear? Okay, just give me yes, Harsha, what is your query? Yes, sir, you started relaxing, but I'm receiving email that I was not able to choose. Why is that so? You can, yes, guys. So please have a word with our operations team. You can just put a word to our in the Telegram group. They will be able to help you out regarding this attendance and all. Clear? Yes. Noor, what is the support column? So support column, you can consider that as the how much is the support from your database? Is it are you considering all your data? Are you considering all the data points that you have considered for your training or not? Okay, because it might vary depending on different model that you're going to have. Okay, here you can have a balanced support and an imbalanced support. So balanced support meaning you can have you will be able to, what do you say, identify between the training and the testing and also able to get the accurate answers. So, This webinar is being recorded. So this is just asking that. No, SVC for non-linear is you have to use RBF. Okay, we had this radial basis function, right? RBF, you can use that instead of linear. Any questions? Okay, let me share my screen. Guys, please let me also stop this. Okay, let me have the answers. Guys, please scan this QR code. I hope my screen is visible, right? So please scan this QR code, okay? Or you can go to join like myquiz.com and then type in this code 387751. Then you will be able to join this. Okay, please do that, everyone. Yes, Shreya, superb. Understand what is happening. We are able to understand as a person, humans, right? What in terms of this one? Here is not visible. It is visible, right? The people are able to join. Please take a connection. So I'll be waiting for a couple of 2 minutes. So until everyone joins, I'm going to wait. And after that, I'm going to start the quiz. Okay. So make sure I am blind. Everybody, you are blind. I made a joke here. Like this thing. You are blind. Don't worry. I'll tell you. It's not an issue. But how are you doing all these labs? Coding and all? Just by listening? Totally blind. Okay. Let's see. I'll give you the permission of co-organizer. But what I'll do is Yeah, confirmation. Okay, wonderful, right? Able to follow? Share all the we grab notebooks in our link. Ignore the information. Stay tuned with all of Okay, Tirupati, don't worry, take it easy. Just take care. Take okay. Tirupati, please. Here also we have this questions. You were able to put 8 questions. Okay. Okay. Guys, what's the quiz? May I end with once this is done, this can we can wrap up. Everybody, don't worry. This will not have any kind of impact on investment. So Rishi, Om, Silkar, and then Sneha. Congratulations to the and the remaining as well for attempting. I know you would have not used any kind of resources. You have okay, good. 67% is the accuracy. Okay, no problem. So claps to all the people who have attempted this. So top five. It doesn't matter. So I for me doesn't matter because depending on the time that you have taken, you'll be getting some credits. Okay, you have to make sure how many right answers are you getting out of those 15 questions. That is what is going to matter. Okay, and moreover, not even that because it is just to check your knowledge, right? You should be in a place to answer or that particular question without having any kind of confusions. Yes, guys. So that's all from my end. So tomorrow, if possible, I'm going to go on with some model training and then model optimization. And then if I have time, I'll also teach about regression as well. And meaning the plan is to have give you an over understanding about the machine learning concepts in this week. So next week I or like end of this week by Friday or like by Thursday, I will be starting off with what is a deep learning. Okay, for you to understand the deep learning, you should definitely have some knowledge in this machine learning concepts. Okay. No, not going to send any kind of practice sessions, but the homework that I need you to do is you have to go back and then explore about SPMs, decision trees, KNN, all these things, and include the same data set. Okay, iris data set sorry ले लो लेने के बाद train करो train test and also try to do with the new data point as well. Yes, okay, no problem. Tirupati, let me share it to you now itself. Yes, guys, that's all from my end. If you have any kind of queries, just do let me know. Okay. I think I've shared it to you in the to your email address. Tirupati, can you please check? I'll be sending all the Google Colab notebooks by end of the day. Don't worry. I'll share it in the drive. Okay. Okay. Cool, Tirupati. Enjoy. If you're having any kind of issue, just let me know. Okay. Yes, guys. Thank you so much. I'll be ending this in 1 minute. Okay. Until then, bye bye. You'll not have any kind of exam or those things. Okay. Mohit, don't worry. Yes, Kushi, yes, everyone. I'm going to share the Google Colab notebooks in our respective Google Drive link. Okay, can find it by end of the day. Okay, bye guys. I'm going to close the meet. Thank you so much for your time.